Howdy, folks. I'm going to go ahead and cut some videos now instead of a little later on. There's quite a bit to cover. Plus, I do want to add some more stuff on during the end of the week that are not in this week's present. It's more of a presentation than it is actual a part where we're going to be responsible for doing some quizzes on. But there are quizzes this week, so just keep that in mind. Uh, this is I'm going to be covering the quizzes in these videos. So they're going to be 3 videos and possibly a couple more particular, well, kind of focusing in on doing scope testing. Some of you will really enjoy getting into scope testing, which is really going to help you with your diagnostic routines. And it takes little bit of a skill to get it going right. But I want to start off with some basic tools and equipment that we use for doing the diagnostic. And it's not always just scan tools and getting into, like I said, scan tools and then getting into fancy scopes. So there's other equipment that are be very beneficial for you to have in your toolbox. So I'm going to go ahead and get started on this particular slideshow. Uh, so we're going to start off with chapter 42, start talking about circuit testing and also diagnostic meters. Uh, the One of the things that I have a few of, and this goes to a lot of my electrical testing that I do, is I have little fuse fuses that I can use for jumper leads. Sometimes you're going to want to jumper across a circuit and you don't know if that's a grounded circuit or not, and you do not want to damage the circuit. So one of the things you can do is make yourself up or purchase some actual fuse, jumper leads. That way, you don't want to use a regular jumper lead unless it's like a ground. But if even with a ground, I would prefer to use a fuse jumper lead. This is going to be beneficial for you when you're doing some electrical testing. And a lot of times when we get into a certain point or the actual, if we want to kind of go into the point where we want to add in a power to a circuit, or we want to jump a circuit, it's a lot safer to use a fuse holder to do it instead of going straight in there and jumper leading it, because you could definitely fry some wire or damage the component. The other thing that a lot of people have is test lights. I'm not a big fan of condensate type test lights, especially when it goes into computer testing. But if you're doing like a bulb, old style car bulb testing and stuff like that, that's fine. But some of the new network systems, you really want to have a test light with either an LED or some kind of something like a 10 mega ohms of resistance to it, so that it isolates itself. So you don't want to have a straight off test light to do your computer networks and stuff like that. This is just showing the different, what we can use to check for testing for grounds, and see if there's actually voltage there too. So what we've done is taken a test light and we've kind of jumpered it between each bulb to see if there is an actual break in the line. And as you can see right here, this light bulb lights, this light bulb lights, but this one didn't. So we know this is why this light doesn't come on, or know why this whole circuit is kind of interrupted along the path here. Uh, One of the things you can do, and it's fairly cheap to do, you can actually build yourself a LED test light, and this is a good way of doing it. We used to do this in some of my electrical classes. We'd actually get an old pin, kind of housing to it, and then we would put a pin through one end of it, put our little resistor in there, and make our own little test light, so it would actually glow when it was powered. And we actually did a kind of a twofold. We had a bulb that would go red, green, and yellow, and that actually allowed us to know where ground was and also where power was, and it's about the way you wire it internally. This is one. It's a logic probe that we use on occasion to check signaling off of a circuit. You can actually, if you have the pulsar that actually pulses across. Sometimes you just get the receiver or you can have one like this that actually has the it pulses in and it can actually pick up the signal, and it's going to blink the lights to tell you if that signal goes across. So sometimes we use these for networks and stuff like that. And of course, everybody should have a DVOM. This is going to be very beneficial for you when you're working in the field. Uh, you can start with something inexpensive, but you really want to get a good DVOM or DMM, as they call it sometimes, because this is going to do a lot of your testing for you. Well, I should say for you, you're going to be using this for a lot of testing. And this one has a multi-feature type of setup, so it really makes it helpful. You can check voltage, you can resistance, you can check some amperage and low amperage on it, and kind of millivolts and mega amps, like there's all kinds of good features you can do it. But this is another thing what I'll be talking about as far as the rest of this week. Here is a kind of giving you the abbreviations of that dial going around. It says, AC alternating current or voltage, and AC is a lot of times when your meters you're going to see kind of like a sine wave, like a kind of wiggly line going across, where your DC is going to be a line with some dashes to it. So this is going to be kind of distinguishing between the two different types of voltage. Then you got millivolts, and then you've got your amperage, and then your milliamps, less than an amp type thing. And then you have percentages on some of your meters, ohms, of course, kilo ohms, mega ohms, more resistance to a circuit. And then we go into hertz and kilohertz. And when we start getting into cycles and frequencies, when we're trying to, diagnose like maybe a Ford older style map sensor, and then milliseconds, for some of the pulsing going on. Here's a nice digital voltmeter. By the way it looks with the case, it's going to be a fluke, and this is actually telling me a typical battery DC reading right now, 12.28 volts. And your meters, you really need to get used to them. You need to find out all about them, read the documentation on them, get some more training on them, because just by not knowing what scale you're on, because a lot of the meters are auto ranging, as I should say, and these auto ranging can throw you off. So if you weren't looking at it properly, you could probably say, oh man, there's okay voltage here and not enough voltage here. And that little bit of differences can actually cause you to be off your specification. So it's important, especially when you get into your resistances. If you're just looking at that, 1.2 and on the meter, but you didn't look at it said kilo ohms, you probably think it's 1.2 ohms. That's totally different readings. You need to really look at it before you kind of say if that's what it is. So right here, I have an actual ohms. If I look down on my scale right here, so I know it's only 1.3 ohms. But if that scale is off a little bit, then it would actually show that I wasn't, that it was, say this was a K over here and said, that's not 1.3 ohms, and this would be out of spec on my bulb here. And that's important too. Make sure you put the correct bulbs in where they're supposed to be, not just something that fits, because actually there's been a few occasions where they can actually take out a circuit, or there was an actual case study of a vehicle that actually had the fleet vehicle, and that fleet vehicle came in that night with a tail light out, and the night crew put in a bulb, but they put the incorrect one, and the next morning the vehicle would not start. And they kind of backtracked it a little bit, so what the heck was done last night? Well, it came in for a bad bulb, and that can't cause it. And they did some research on it, and they found out that bulb had too much resistance in it, and the network actually shut that whole system down, so it wouldn't start. Good idea to do on all your meters, because your leads will have a little bit of resistance to them. It's better to go ahead and zero it out. If you don't have a meter that actually will zero out the resistance, because a lot of times there'll be one you push a button that it zeroes it out. This one here does, but some meters won't. You're going to have to either write it down or remember it in your head, put a little memory thing in your head saying, okay, that's 0.1 ohm of resistance, and you're going to subtract that from your actual reading. So this is a good way of doing that. And here, yeah, we're checking for amperage across. Now, be careful with your meters. Some of the meters, well, I should say most of the meters, do not allow over 10 ohms of, I should say 10 amps of actually current flow. Above that, it can actually destroy the fuse inside the meter, uh, or it can do, depending how expensive your meter is, it can actually do other damage. This one here, the flutes actually have a pretty expensive fuse in it. One of the things I like to do with my meters, if I'm doing amperage testing, is always have a second set of leads. And then what I do is I put in an inline fuse in one or the other side of the leads, and that will allow me to pop that fuse before I pop the internal fuse. And that's what I've been doing for quite a few years. And it saves my meter if I do something silly and I have a circuit that I anticipated only being a couple amps, and then I hook it up and it actually has above 10 amps. That would have destroyed that fuse in my meter. But since I put that fuse in place, it saved me from doing that. One of the other pieces of equipment that you'll use is actually a inductive lead to actually check for amperage. This is right here is an inductive lead. It picks up the actual radio frequency off of the voltage traveling, I should say the current traveling through that actual lead. And what they're doing right now is they're loading up this battery to test it. But what I'm trying to get at is we do different types of pieces of equipment to help us diagnose things. And this is one of the pieces of equipment we do. We'll test batteries with this particular type of equipment. Our newer testers are actually, better, more sophisticated, and they're actually handheld now too. So this is just one of them that we use for charging and starting systems. And again, we're using a clamp-on mini clamp type one. Some of these actually have different sized jaws, which are pretty cool. And you can change the jaws around, and that way you can get around a bigger cable or a smaller cable. And this is to check amperage going through. So this is that current going through, and now you can actually jump up higher on your current flow instead of the way we did with the meter where we could actually have blown that fuse. This is going to pick that up. Here is an actual typical, meter showing that's out of limits. So the resistance on this particular one, it looks, yeah, it's way beyond. It's almost like leads being out. Like I was talking a little bit earlier, you need to be very conscious of the actual reading when you're looking at the scale. Make sure you're getting the right area. This could be a mega ohms, it could be a kilo ohms, it could be just an ohm, and that can actually throw you off too. Here's just the breakdown of how spaces the zeros are when you're looking at the scale, and it tells you, it kind of gives you a cheat sheet on what that conversion is. If I were to look at, okay, this is telling me it's so many mega ohms or so many kilo ohms. And then here's kind of a chart for, some of the auto ranging functions on some of the vehicles. So I should say not vehicles, but some of the meters. So it's best that you know where this is laid out, because again, a lot of the meters are set to auto range, and if you don't pay attention, you can actually be off by quite a bit. And here's actually showing an actual meter, a flute, like they said before, showing some of the comparisons. Now, this is what, why I'm kind of a fan of the actual DSOs or the oscilloscopes, because this is an oscilloscope screen right here, and this is a meter. Now, this is showing the same thing here. This does not have a very good refresh rate, but you'll notice they sit on the min-max scale on this, and this is another thing hopefully we'll have time to talk about this week. But this min max part, okay, they're actually only showing the max right here on this particular screen. So it shows 6.54 volts, but look at what's happening on the screen. It's going below the zero line, and it's actually probably showing a peak to peak of somewhere around 12 volts. Now, that didn't capture in this meter, where an oscilloscope would. Here's another good example here too. So this is all pretty much a, kind of averaging on this also. I do see some fluctuation, but see what's happening with the screen. It's bouncing up and down. It's showing the positive and negative scales, and this does not pick it up, but it is an alternating current. So this is one of the things that you got to be careful on. So this meter display shows 52.2 AC volts, something you might see at a speed sensor, something like that. So the zero inside the 5 indicates that the meter can read over 100 volts AC. So you can actually see how that has the 0.52. It actually could go up to pretty close to 999 if it wanted to. And one of the things that you want to be very aware of is the leads and your meter's capabilities. Now, some of the meters are not insulated. And what I mean by that, if you really did get into high voltage and anything like above 50 volts, you could actually get a little shock to it. You get into the 100 volts and you get into 300 volts, and like some of the hybrids, you do definitely want to have special equipment. But this is kind of nice to know that this equipment, okay, is insulated up to 1,000 volts on this one particular. This is a Cat 3 certification on this particular one. Cat 4s go, I believe it's 600 volts. So I would have to look at specs on that too. But you want to make sure they're using equipment that is capable of it. You don't want to get yourself shocked in the middle of things too. This is another, type of a lead that is insulated, and it's even more insulated. This is what's kind of neat about it. So let's go through a little bit of a digital meter usage. Here we actually see a meter that we're using, and we're actually looking at voltage right now. And if we put it onto voltage here, and then I'm going to go ahead and hook it up to a battery. So this shows which is a booster pack here, 13.15 volts. And we look at the scale here. So notice that the voltage scale DC, not an AC, but a DC. This is an auto range right here. And if I look at it again, kind of pull it back. If you look right here, it's actually ranges up to about 40 volts, it looks like. And then if I take my ohm meter, put it on the ohm scale, this omega sign right here. So remember, see, this is the DC voltage here. This is my millivolts down here. And this is my voltage AC. See that wiggly line right down there? And then we're measuring just the resistance of our body. Our body has a certain amount of resistance, but look at, we're actually showing about 29.110 kiloohms. That's a lot of resistance in our body. And you can do it yourself with a meter. And here we're checking the resistance on this particular bulb. Now, one thing I want to caution you from doing, you don't want to have your fingertips on the glass of the bulb, because your fingers have a little bit of oil on them, and it will shorten the life of the bulb if you do that. I prefer to take either a tissue or take a cardboard that a lot of these come in, and put it around the bulb itself and hold it from there. If I'm going to want to actually measure that bulb, and I'm going to measure both terminals and also that one, the ground and also that terminal, I'm going to actually not want to have my fingers on it. If I put my fingers on, I've just put more resistance in it too. So that you may have it may not be a whole lot, but you're going to have a change in resistance on it. So it's showing here. Right now I'm checking my it looks like I'm checking my leads. And then I'm going to check for AC voltage here. So this is my scale for AC voltage, DC voltage here, millivolts, so that's less than a volt, and this is direct current here. And then my resistance, and here we're actually just showing the scale of mega ohms on it right now. And I'm checking here, we're actually checking, it's a diode checker. So here, some of the devices on your vehicle has diodes, so little one-way check valves, and this is going to actually check that. I'm ranging it, getting auto ranging. I'm recording right now, so I have a min max. I have actually a little bit of ranging going here. So this is range. Almost looks like flange, but it's actually range. And I can change the range, and I can actually change it across. So 4,000 volts here, 4 volts DC. All right, so that was kind of like a quick little overview of different types of test equipment. I want to break it down a little bit more, so I look forward to more videos as we go through the rest of the week. I'm not going to hold you accountable for testing on this one. I will, and there's going to be 2 other ones I'll hold you accountable on the test. But please understand, this is the extra stuff I'm putting on is going to be beneficial to you. Remember that if you have any questions, please feel free to reach out to me and also to Mr. Andreessen. We will help you as much as possible, but you've got to do the work yourself. If you have a question for either one of us, please go to the inbox and inbox us that way. If you have a general question, please reach out to the discussion group and talk to your fellow students. And it's a good way of networking and getting to know each other. You never know when you might need their help or possibly get yourself into a job. So for now, this is going to end this session, and there will be another session up pretty soon. All right, talk to you soon. Take care.